These are the second video of the notes for Algebra 2, section 4.4, factoring polynomials. All right, where we left off was ready for example 3. So it says to factor this polynomial completely. Now notice it has 4 terms. Z cubed is a term, 5z squared is a term, minus 4z is a term, and minus 20 is a term. So it has 4 terms. So what that tells me to do is do something called factor by grouping. And there's several ways to do this. Personally, I like to do it using the box method. So when there's 4 terms, I just immediately go to factor by grouping. And what I'm going to do is I'm going to draw a box with 4 places. Now, when there's 4 terms, you don't have to do what multiplies to AC and adds to B. That whole thing is when you're factoring a trinomial, meaning 3 terms. So you put each term in a box. You can have Z cubed plus 5Z squared minus 4Z minus 20. Okay, so what you do is you look and you try to find the, you try to go ahead and find the GCF of each row. So what we're going to do is what comes out of Z cubed and 5Z squared is Z squared. That's the greatest common factor. What comes out of negative 4Z minus 20 is negative 4. Remember, if this box is negative, you pull out a negative. If this box is positive, you pull out a positive. It controls it. Now do this column. What comes out of Z cubed minus 4Z is just Z. Do this column. What comes out of 5Z squared minus 20 is 5. And because this top right box right here is positive, you pull out a positive. So what we have right now is we have Z plus 5, and we have Z squared minus 4. Now, Z squared minus 4 is difference of squares. All right, remember that is something that we learned in Algebra 1, and we also referred to in the last video. And so what we can do is Z squared minus 4. It's 2 perfect squares subtracting. So you square root the Z squared, you get Z. That goes here and here. You square root the 4, you get 2 here and here. And 1 is plus and 1 is minus. All of that together is your fully factored polynomial. Okay, looking at this one, it says factor this completely. Now, notice this only has 2 terms. So the first thing I do is I look for a GCF. There's nothing I can factor out of this. So the next thing I notice is both 16x to the 4th and 81 can be square rooted. So this is another difference of squares, because it's 2 perfect squared things that are subtracting. So you can square root the 16x to the 4th. The square root of 16 is 4. The square root of x to the 4th is x squared. And then you can square root 81, it's 9. And 1 is plus, and 1 is minus. Now, once you do that, this is difference of squares again. So this one can break down farther. Okay, so we still have 4x squared plus 9. And then the 4x squared minus 9 breaks down again because the square root of 4x squared is 2x. The square root of 9 is 3. 1 is plus and 1 is minus. The reason the first parentheses doesn't break down, this 4x squared plus 9, is because it has a plus and there's not a formula for sum of squares. That's not a thing. So difference of squares is the only one we have. We don't have something when there is a plus and it's a binomial that's being squared. Okay, so let's look at this one. The first thing I always do on these is look for a GCF, a greatest common factor. So a GCF that could come out of here, 3 goes into everything, and p squared. So I'm going to divide everything by 3p squared. I like to show it just so I don't mess anything up. All right, so if I do 3p to the 8th divided by 3p squared, the 3 cancels out. P to the 8th divided by p squared is p to the 6th. what's happening there, I'm just going to scoot off to the side and show you. When you have something like that, you're subtracting them. You do 8 minus 2 and you get 6. The reason why that works, if you picture p to the 8th, that's like p times itself, 4, 5, 6, 7, 8 times. And p squared is like p times itself 2 times. So if you notice, what happens is one set of p's cancels out and another, and what you're left with is 6 of them. So it's p to the 6th. So when you subtract, really what you're doing is saying how many did not cancel out. Okay, 15 divided by 3 is 5. P to the 5th over p squared is p cubed, because 5 minus 2 makes 3. 18 divided by 3 is 6, and p squared over p squared cancels out. Okay, now what you're going to do is you're going to factor what's left inside the parentheses. So if you look at this piece right here inside the parentheses, it's a trinomial. So it can be factored using, I'm going to come down here to do it, what multiplies to AC, which is 6, and adds to 5. And that's going to be 2 and 3. So what I'm going to do is I'm going to use the box, and I'm going to have p to the 6th here and 6 here. So I have this first term, p to the 6th, is on the top left box, and then this 6 is on the bottom right. Now you use the 2 and the 3 in these two boxes, and normally we just use p, but if you notice, 2 and the 3 are making 5p cubed, so you need to use 2p cubed and 5p cubed. All right, so if we go there and we try to factor this out, this is p cubed comes out of this row, and 5 comes out of this one. And, oops, I'm sorry, I wrote that down wrong. That's not a 5, that was supposed to be 3, because our numbers were 2 and 3. There we go. So 3 comes out of this one. This is p cubed, because p cubed times p cubed does make p to the 6th. When you're multiplying and they have the same base, you add the exponents. You do 3 plus 3. That's how that works. And then a 2 comes out of this one. So it's p cubed plus 3 and p cubed plus 2. And all of this combined, don't forget that 3p squared out in front, is your answer fully factored. Okay, that's everything new we have to learn. Let's go ahead and do a few examples. So let's talk through how I know where to begin. So on number 1 right here, I see it's a trinomial, but I also look for a GCF first. So an x can come out of everything. So it gets x squared minus 7x plus 10. And that's because I divided everything by x. And so then that factors very nicely. If you look at that inside the parentheses right here, is going to make this parentheses and this parentheses. So if you look at that, what it does is it multiplies to 10 and adds to negative 7. And so that's going to be negative 5 and negative 2. And because it's just x squared, there's not a number in front of the x squared, that's the quick type of factoring, where we can just go ahead and write it down. We don't have to use the whole box. If we did use the whole box, that's fine. Okay, on number 2, I see there's 2 terms, so I'm hoping it's difference of squares. Currently, you can't square root 3 or 75, so look for a GCF first. The GCF I see is 3 into the 5th. 3 goes into both, and then you have to factor out of the end of the 7th into the end of the 5th. You choose the lower one. So we're taking 3 into the 5th out. What's left is n squared, and 75 divided by 3 is minus 25. Now, that in the parentheses is difference of squares. It's a perfect squared minus another perfect square. So the square root of n squared is n. The square root of 25 is 5. And one of them is plus and one's minus. And all of that together is the factor of that binomial. Okay, so looking at this next one, how I would approach it is I'd look for a GCF first. The GCF I could pull out is 8m cubed. All right, and so I would pull out 8m cubed, and what's left at that point is m squared minus 2m plus, this cancels out right here. This is kind of weird. 8m cubed divided by 8m cubed. All of that cancels. You don't just make it go away. It makes 1. When you do 8 divided by 8, you get 1. You have to have something there. So that looks like that will factor easily. It makes multiplies to 1 and adds to -2 is -1 and -1. So it's m minus 1 times m minus 1. And we want to write that instead of m minus 1 times m minus 1 as m minus 1 squared. That's really the better way to write that. Okay, let's look at this one. This one is a review from video 2, or from video 1, I'm sorry. It's sum of cubes. Do you see that a cubed is cubed, obviously to the third power, and 27 is a perfect cube. It's on our list. 3 cubed is the same as 27. So this is the sum of cubes, which I'm just going to write down the formula real quick. When it looks like that, you do a plus b, and then in the next parentheses, you do a squared minus ab plus b squared. All right, so our a is literally just a. That makes that pretty easy. So everywhere there's an a, we're going to plug that in. And our b is 3. So anywhere there's a b, we're going to plug 3 in. So what we have is a plus 3, a squared, minus a times 3 is 3a, plus 3 squared is 9. And that would be that answer. So just looking ahead here on this one, I would factor out a GCF first, and then I would see what's left. It's either difference of squares or difference of cubes, and that's what I would look at. So like right here, my GCF I could pull out of everything. Let's see here, I think this is divisible by 6, z to the 5th. So when I do that, I'm left with 1, or sorry, z cubed, 1z cubed, minus 125, which is totally a difference of cubes. And so I can use the difference of cube format. I would have to write it down. It's a minus b. So remember that 5 cubed is 125. So this is like z cubed minus 5 cubed. And then it's a squared, which our a is z, so we put z squared. And then it's plus ab. So plus z times 5 is 5z. And then it's plus b squared. So 5 squared is 25. So on 6, I see it has 4 terms. I would do factor by grouping. That's where I'll just get it set up for you. You go straight to the box and you figure out the GCFs. So then I pull out x squared minus 1. Here I'd have x plus 4. The thing you have to be careful here is usually something factors again. This is difference of squares. It goes again. All right, so x squared minus 1 becomes x plus 1, x minus 1. That's because the square root of x is x and the square root of 1 is 1, and you do 1 plus and 1 minus. So these last 6 questions I just kind of went through quickly because they're just review.